your Kalpana here. So in this video we are going to evaluate two integrals. Okay. First one, evaluate integral 1 by 1 plus sin x into dx. So here we are going to rationalize the denominator. For that we are going to multiply and divide with 1 minus sin x. Okay. So this equals to 1 minus sin x by 1 plus sin x into 1 minus sin x into dx. So this is of the form a plus b into a minus b, which is equals to a square minus b square. So this is equals to integral 1 minus sin x by, you could write it as a square minus b square, that is sin square x into dx. Okay. Since we know that sin square x plus cos square x equals to 1. So from this we'll get cos square x equals to 1 minus sin square x. So in the next step we can replace 1 minus sin square x by cos square x. So this is equals to integral 1 minus sin x by, now we are going to replace 1 minus sin square x with cos square x into dx. So this equals to integral 1 by cos square x dx minus integral sin x by cos square x into dx. Since in the numerator you are having two terms and in the denominator you are having one term, so you can split the total fraction into two fractions, or you can split the the total term into two terms. Okay, since you are having two terms in the numerator, so we have divided the term into two terms. So this equals to, since we know that reciprocal of cos x equals to secant x, if you square on both sides you'll get 1 by cos square x equals to secant square x. Okay, so now you could write it as secant square x into dx minus, here you're having sin x by cos square x, so you could write it as sin x by cos x into 1 by cos x into dx. Okay, so this equals to integral secant square x dx minus integral, since sin x by cos x equals to tan x, so you could replace sin x by cos x with tan x into 1 by cos x with secant x into dx. Okay. Since we know that integral secant square x dx equals to tan x plus c, and integral tan x secant x dx equals to secant x plus c. So this becomes tan x integral secant square x is tan x minus integral tan x into secant x is secant x plus integral constant c. Okay. So therefore integral 1 by 1 plus sin x into dx equals to tan x minus secant x plus c. Okay, this completes the first integral. Now coming to the second one. evaluate integral 1 plus cos x. So here in the denominator we are having 1 plus cos x. So we are going to rationalize the denominator by multiplying and dividing with 1 minus cos x. So this equals to integral 1 minus cos x by 1 plus cos x into 1 minus cos x into dx. Since this is of the form a plus b into a minus b, you could write it as integral 1 minus cos x by a square 1 square minus b square is cos square x into dx. So this equals to integral 1 minus cos x by sin square x into dx. Since we know that sin square x plus cos square x equals to 1. So from this we'll get sin square x equals to 1 minus cos square x. Since we are having 1 minus cos square x, 1 square is equals to 1. So here you are having 1 minus cos square x. Since 1 minus cos square x equals to sin square x, now you can replace 1 minus cos square x with sin square x. Okay. So this is equals to integral 1 by sin square x minus cos x by sin square x into dx. Okay. So we could write it as 1 minus sin square x minus cos x by sin x into 1 by sin x. Okay. Since we know that reciprocal of sin x is cosecant x, if you square on both sides, you'll get 1 by sin square x equals to cosecant square x. And also we know that cos x by sin x equals to cot x. So this becomes integral of 1 by sin square x, which is cos square x, minus cos x by sin x is cot x into 1 by sin x is cosecant x into dx. Okay. This is equals to integral cosecant square x dx minus integral cot x into cosecant x dx. Since we know that integral cosecant square x dx equals to minus cot x plus c and integral cot x into cosecant x dx equals to minus cosecant x plus c. So this becomes minus cot x minus integral cot x cosecant x is minus cosecant x plus integral constant c. So this is equals to minus cot x minus into minus plus cosecant x plus c. So therefore integral 1 by 1 plus cos x into dx equals to minus cot x plus cosecant x plus c. So this completes the problem. So we have seen two integrals in this video. Hope you will understand. We'll see you in the next video. Until then, bye bye.